So we like to think of it as we need to scan everything. We have the ability to capture high-quality 3D data at extreme ranges, at high speeds. When we think about reality capture, is it really just scanning? Is it really just UAV? Or is there more technologies that really provide us this reality capture capabilities? They're making their way into more products. They revolutionized laser scanning, and they're also making it possible to turn GNSS smart antennas into reality capture devices. What we're seeing in the industry now from geospatial companies and reality capture companies is the merging of technologies. They're crossing paths, and they're making tools better for us and opening up more opportunities for us to be able to provide data to our clients. Hello, everyone. We're excited to be here this week as part of Leica Geosystems. Take a moment to introduce myself. I'm Joshua Rayburn, again with Leica Geosystems, and I'm the business manager for reality capture in North America. And when we look back in reality capture, it's hard to believe that, it was over 20 years ago when Leica Geosystems bought the company Cyrex, and first really helped the reality capture industry really come to market with laser scanning. And we've continued to lead in this innovation, over these last couple of decades. And when I look back about how I ended up here today, reality capture is really what changed my career path. And that was right at 20 years ago. The first time I seen a 3D point cloud and got immersed in this 3D environment, I was hooked, and I've been doing it ever since. I was started as a project manager at a civil engineering firm, and at that time, I can remember, evaluating the different technologies out there and thinking about me and my team kind of going down this exciting uncharted path at the time. And we started with much like this. It was this huge scanner. It scanned at a 30-degree window. You could only rotate at 20 degrees because you had to have this overlap. I remember evaluating technologies. They could finally spin 360 degrees, but you had to get them in these very odd positions to be able to get that correct field of view to be able to capture that object of interest. And things have so changed. When I started, one of the big drivers behind the project was this year-long project of over 100 bridges. And to create our deliverables took over 2 days. 6 to 7 months into that project, an evolution in software changed that to like 20 minutes. And we continue to see this technology change. Even through some of the major troubles, right? I can remember starting early on, and the software didn't understand the difference between feet and survey feet. Big problem when you're trying to get to control. But a lot has changed, no different than our smartphones in our pockets. We continue to change at a faster rate. And I think us as manufacturers, or you as users, we always have to be prepared and forward thinking about this technology. So I'm sure many of you in this room are just like me. You've been doing this since the very early days of the technology. And maybe some of you started in the last 8 or 10 years with a product like the Leica ScanStation C10, which is still a workhorse in the industry today. Or maybe you're really just starting to embark on that journey of reality capture. But regardless of what you've learned through experience or from mentors in the field, you're probably really familiar with a lot of the basic truths or conversations that we continue to hear about reality capture. And that's what we want to discuss today. We really believe, much like what started this network, is it's about the education and knowledge and spreading the word. So for example, one of the common themes we always hear is it makes sense to have a reality capture project before you invest in reality capture, so you can quickly pay back your investment. But is that really how we should be thinking about this technology now that we're over 2 decades into it? So one of the big things that we always hear also is there's a significant amount of time saved in the field, that the hardware has evolved so far. And this fast data collection and laser scanning is usually offset by the time that is required in the office to align the data, to process the data, to clean the data, so we can actually get those meaningful deliverables from the data and provide them to our clients. I think if I took a measurement right now, not necessarily in this room, but everywhere the people I talk to in reality capture, this would come back in a 50-50 response in true or false. And I think that really depends on how long you've been in laser scanning or whether you're really just starting to embark on that journey in laser scanning and reality capture. And continuing to educate yourself and your team is probably what really drives the difference between that boat. But some of the newer technologies, I think, is what's really bringing us this kind of one-size-fits-all. And it certainly really sounds attractive from an investment standpoint. And the technologies allowed it to be more of this all-purpose tool. the ability to do more with less, the ability to take on more types of projects and only make a single investment. But is it truly the only place we should stop? When I think about the smartphone in my pocket, I would love to be able to do everything from my iPhone, but I still have to pack this laptop with me at least 40 or 50% of the time because I need more than one tool to do my daily job. As for mobile mapping, which I've spent a big part of my past 5 and 6 years involved in, one of the truths that I always hear that I would battle whether it's really the truth or not is it's a fantastic tool if you're doing a roadway project, but I don't have DOT contracts. But I don't do enough of this type of work. But is it really only locked to roadway projects when we think about all the different types of mobile mapping that's out there today? And also, one of the kind of challenges and conversations that continue to be out there is when I see people that have been doing this for a few years and they've continued to do it with terrestrial laser scanning, they see that there's this demand to do their work and they always require this highly accurate point cloud. If it's going to be measurable, if I'm going to create as-built and I'm going to create floor plans. And the assumption is I can only ever continue to use a tripod laser scanner because that's the only way to get the correct type of data that I need for my type of projects. Also when we think about laser scanning, right, it's the most known way from a tripod, maybe some of the handheld devices today, and also UAV. It's the most common way to think about capturing point cloud data. From UAV, it may be an onboard LiDAR system, or it may be actually converting photogrammetry to LiDAR. But are these only the ways today when we think about reality capture? Is it really just scanning? Is it really just UAV? Or is there more technologies that really provide us this reality capture capabilities? So when I think about some of the items that I just presented are challenged in regards to everyday conversations about reality capture. Would we think that they're right? Would we think that they're wrong? Or is it somewhere in between? And that's really what I kind of want to revisit some of these slides I've just presented and talk more about where we see that from Leica Geosystems. And over the last 5 years, technology has really changed in reality capture. It's been a remarkable evolution of what's happened. And it really requires us to rethink our ideas and how we utilize reality capture for our projects and for our clients. And if we're not, more than likely we are being left behind in this industry. So with the introduction of laser scanner, we see a lot of different scanners here, right? We see some very high end, we see some middle, we see some low end, but all of these have this ability to capture accurate data. We have the ability to capture high quality 3D data at extreme ranges, at high speeds, and in extreme environmental conditions, along with entry-level technology that is simple to use and allows the barrier of price to be broken down to allow more people to be involved. When we look at this, reality capture is no longer about a specialty application, and it no longer just requires the right project to make an investment. You don't need that project to invest, and in fact, more than likely, everything that we see daily in discussions with users and other manufacturers out there, and what they see is, if you're waiting for that right project, you've already missed out on significant opportunities to grow your business. And the leaders in the field of reality capture, they're achieving remarkable gains in efficiency and productivity and new business practices because they continue to practice this principle of investing in the technology and educating their teams and building out that knowledge base. So we like to think of it as we need to scan everything. When we think about software, innovation has truly streamlined workflows. And it has eliminated much of that idea that we have to take the data from the field to the office to get actionable information. Software that runs on mobile devices, tablets, and phones, the ability to pre-align data in the field, the ability to share it immediately to the cloud and make it available to existing stakeholders that need to make decisions and make important decisions before you actually return to the office. You can conduct on-site quality controls and add so much more value to this 3D data, whether that's geotagging measurements, images, additional images, voiceover, so much more can be attached to that point cloud that it provides intelligence and provides the end users of the data the ability to make better decisions. And this can all happen in the field from your tablet. So next I want to explore one of these workflows. And the software advancements that's making this actionable information available is coming more and more online every day. So here is a video that I'm going to walk you through. So here we're going to start the scan position. So this example is using the RTC 360 as well as Field 360 on a iPad. So we start the scan. We can see that it positions the scan in that position. It's going to complete. And once it completes, We see the data arrive, and now we can actually walk to the next position, and the viz technology in the RTC automatically tracks where it's going. We can see this live in the data set. You can start the scan, and immediately those two scans will come together, and they'll recognize that they're linked together. And it will then bundle those together and optimize the registration. So the technology in the hardware allows it to be tracked and pre-aligned, and then the software allows it to be bundled for enhanced accuracy. Once that happens, then you can actually use a slider bar and tell it you want to create floor plans. You'll see that it's created a slice view, and it's already found a couple of the walls. It'll find more walls automatically, and if you see something like an offset in the wall that doesn't have the proper alignment, you can then use smart snaps for it to actually help you align where it should be going and continue around that room. Once the entire room is complete, it's not just about being in 2D. So it's around the 3D, and it gives you that ability to add a floor elevation and a ceiling elevation, and it extrudes that 2D floor plan into a 3D entity. Once that's complete, it automatically walks you through a wizard-driven workflow, and it says, do you want to add windows and doors? And then it'll bring back open that imagery with the point cloud supporting it in the background, and you can select on the door frames. So remember, we already know the floor elevation from the previous step, so we just got to select 3 points, the left and right side of the door frame and the top of the door frame, and it automatically adds those doors into that 3D model. Once that's complete, you can then move on to other door locations and other window locations and add as many as you need. And we can see here that the floor plan is created, extruded in 3D with doors and windows in place. This can immediately be saved, additional settings been made, and it can be exported immediately and shared with project stakeholders back in the office or in other locations. So come back to my comment earlier about the all-in-one scanner, this ability to be versatile. It's a fantastic way to get into reality capture, and I would never advise anyone against it because it opens up new doors for you to start that journey in reality capture to build out a bigger business. But what I would say is you shouldn't stop that journey there. When I think about that, and we think about the tools in the toolbox or how we drive efficiency to projects, when I come here this week, I looked at how I was going to travel. I'm from Charlotte, North Carolina. The car was not the best option. So I got in an airplane on Monday and I flew to Boise. But my journey didn't end at the airport. I still had to get to my hotel that's 2 blocks away because I needed to be here this week. So that involved me getting into a car. So the best part of my journey happened because I had multiple tools to allow that to happen. And that's ultimately how we need to think about reality capture that allows us to evolve. As we have different solutions now, there's so many new innovative solutions out there that allow us to drive after many different applications that you owe it to yourself and your clients to constantly re-examine your toolbox and your way of doing these projects. Having a fit-for-purpose tools for every application opens significant opportunities and give you greater confidence in what you can provide your clients. Coming back to mobile mapping. So innovations in mobile mapping have advanced the technology well beyond roadways. And it's now a multi-purpose tool that is only really limited by your imagination. When we think about mobile mapping, the conversation usually begins with most people that I talk to about vehicle-based mobile mapping systems. But mobile mapping is more than that. It's backpack, it's the wearable devices, it's the handheld devices. It's much more than just vehicles. And they open up new opportunities, and we're really only limited by our imagination of what can be done with mobile mapping. This image in particular reminds me of a project we were able to help a customer find a solution. They had looked at UAV, they had looked at other technologies and trying to be vehicle-based mobile mapping. But it was all about vegetation encroachment on power lines and eliminating fire. But when we looked at it, it was inaccessible. It was far away from major roadways, and there was no way for vehicles to access. The vehicle-based mobile mapping was out of the question. In regards to UAV, flight times, line of sight, it was out of the question. And what was not out of the question was the ability to walk the pass within these right-of-ways. And often they had four-wheeler pass, ATV pass there. But we needed something that continued to be versatile enough that it could be used both ways. The backpack supported that project for hundreds of miles of data to be collected and to help eliminate fires in the wild that spark due to electricity. And when we think about vehicle-based systems, the roadway thing still stands strong. It's still the major player when it comes to mobile mapping, but it's well beyond those DOT projects now. Telecommunications, public safety, construction, and so much more are really starting to drive these technologies beyond the industries that we always know them to be for. So now to get back to this idea about the accuracy of a point cloud, that, to get my project done, I need to use a terrestrial-based scanner. The only way that we can really get beyond this is to allow our skepticism to move beyond our thinking. And these newest innovations are really challenging this type of principle that we need to use a tripod scanner. The BLK Go handheld imaging laser scanner, for example, introduced in 2019, is one of those. It provides high-speed data collection, full 300-degree spherical imaging, and it does it with enough accuracy that it is more than sufficient to complete many reality capture projects. And the same innovations that drive products like the BLK Go and the RTC 360 using VIS, as we refer to it, VIS, which stands for Visual Inertial Systems, they're making their way into more products. They revolutionized laser scanning, and they're also making it possible to turn GNSS smart antennas into reality capture devices. The GS18I, for example, was what was captured to create this point cloud. What we're seeing in the industry now from geospatial companies and reality capture companies is the merging of technologies. They're crossing paths, and they're making tools better for us and opening up more opportunities for us to be able to provide data to our clients. And with all these advances, it's definitely clear that reality capture always needs to be evolving, and we need to be evolving with it in the way that we think about the utilization of the tools that are made available. So next is the concept of autonomous reality capture. We've seen this evolving now for a couple years. With autonomy, we have the freedom to collect anywhere we need, and we can do it fully remotely. We don't have to be on site. Autonomous sensors capture data safe, repeatable, fast, and can provide us data on more consistent timelines that are more complete. And the captured data can be shared in real time through cloud-based storage systems for visualization, collaboration, and more, instantly available. One of the big things about considering that you have full autonomy, it's not the ability to capture the data without human intervention, but it's also the ability to process the data and make the data readily available in real time. That's what full autonomy is all about, and that's what we're driving with our announcement of the BLK ARC and the BLK Fly sensors from Leica Geosystems. These are both brand new to market as of early September, and I'll begin shipping later this month to customers. First, let's talk about the BLK ARC. ARC stands for Autonomous Reality Capture, and I got a video to let you see the system in action. Okay, so that was the marketing video, but this is a real project that we completed with BLK ARC, and I kind of want to talk you through what's going on here. So this is one of those areas where autonomous reality capture proves so valuable, right? When we think about hazardous conditions, dangerous areas, and one of the great things that we've all been using reality capture for years is this ability to be able to reach out and capture information without putting anyone's in harm's way. But sometimes those line of sight objects are into tunnels, they're in mining. Maybe they're in a fire investigation, and we need ways to get there. And we've seen the solutions on the market now for a couple of years, and there's some really unique advantages in what BLK ARC is bringing to market. So it's a mobile device. It's capturing mobile data in real time as it's walking. But we also know that there's a need sometimes for that higher density, higher accuracy static data. So in the mission planning of this, which can happen remotely from anywhere in the world, you can actually tell it to do static poses at any given location. And then that data is filtered back in the office. You can use a combination of both or whichever one you prefer. So whether you're on site or 1,000 miles away, you have full autonomy. The data is complete, it can be processed, and it can be then uploaded live in real time. So here you can see a finished product that comes from the BLK ARC inside of this project. And the focus here is we also know that there's the ability that some projects, this comes back to the idea that the journey shouldn't end with one sensor, that there's projects where we can send humans and we can use other reality capture devices. But maybe there's that hazardous location where we can't access. And the process behind these different products like BLK to Go, BLK ARC, BLK to Fly, which we'll visit next, or the RTC 360, is they have a common workflow in the office where we can merge that data and utilize it in one unified point cloud for the benefit of the downstream users. So next, we're going to talk about the BLK to Fly. This is not just another drone with a payload. It's a fully integrated flying imaging laser scanner. Cameras are integrated on board, the scanner is integrated on board, and it uses autonomy to make decisions in the field. So that's 21 inches by 24 inches or 5.7 pounds to bring it into our system. So here's another video that I'm going to talk through some of these features of the BLK to Fly. So when we think about the full autonomy, yes, there is a pilot there with the system. But what the autonomy is its ability to make decisions, not only in its flight path, avoid obstacles and return to that flight path, but as what you'll see here in just a moment, there's a street pole along the sidewalk. It will avoid that and bring itself back into its flight path to collect the correct data. So with that, it's also making decisions in the field about how far to be away from an obstacle and be able to get consistent data density from one end to the next and make sure it doesn't have shadows in the data. And this is live streaming the point cloud to the user interface of the controller. So we can see at any given time if we have shadows, if we have missing data, so we can make the right decisions in the field to make sure we go back and collect that data before we get into the office to process data and realize something is missing. We've all been scanning buildings for years with terrestrial scanning and asking special permission to get on roofs. Now we have a workflow that combines the greatest things about reality capture of imagery and point cloud in a combined tool, integrated tool in the BLK to Fly that can capture everything. But if you still prefer to have a ground-based solution, the data sets can be completely merged and unified together for an all-inclusive data set to create your digital twins. And I mentioned earlier, it doesn't have to stop there. With these solutions, we're all about getting data in the cloud in real time, and managing the data is also becoming so simple. So with BLK to Go, BLK ARC, and BLK to Fly, we now have the ability to upload this data automatically to HXDR. HXDR stands for Hexagon Digital Realities, and it is released in a preliminary status at this point. We'll be fully ready for the public in Q1 of 2022. But it is more than just online storage. It has collaboration, visualization, and today it automatically takes these files and creates texturized meshes without user intervention. And there's more to come in this platform. It's not just about visualization and collaboration, but it's all about processing, the ability to do validation, progress monitoring, and construction. All of these capabilities become available in the cloud in a single tool set that can be available to multiple users, whether they're internal or external to your company. So how do we make these smart digital realities happen inside of HXDR? It's all driven by using artificial intelligence algorithms that automatically understands what we want it to do with the data upon its arrival. So it comes less about the technical aspects of how we capture the data and less about the technical aspects of how we're going to process the data, and more about making the data readily available to those stakeholders that need to make decisions. So this past year, in the spring of 2021, we actually got an opportunity working with one of our customers, Morrison Shipley, to really kind of challenge some of the things that I've talked about today. A big, user of terrestrial-based scanner, and they had a huge project in front of them. They had multiple, hundreds of thousands of square feet across 16 different project sites, and they only had 3 weeks to complete the project. And they were honest with us. They were skeptical of the idea of using a device like the BLK to Go or other handheld technology. But we went in, we explained the technology, we showed them the value, we showed them the quickness of the solution and being able to continue to meet data that was sufficient for that type of project. And in the end, they met their project goals, and they continued to innovate their company in the way that they provide their clients reality capture capabilities. And in the end, they saved 41% over their estimated time to do it with a terrestrial laser scanner. Again, we've continued to see some of the success. And here, I think more about the bottom line of what we're doing with technology. Technology is not the end game. The innovation in the sensor and the software is only part of the story. And the imagination that you bring to your work and the creative ways that you start to apply this technology is ultimately how you'll drive your future in reality capture. So as I come to an end today, my question to you is, are you willing to challenge your assumptions and push the boundaries of what this technology that's been provided to you with the innovations that we continue to bring forward to change the way you do business? Are you continuing to learn? Are you looking at the truths and continuing to explore and keep learning and keep running at new ways to discover? We always got to be doing this. So with that, I come to a close, and I want to welcome you to speak to us this week over the next couple of days about how we can help you innovate in reality capture to bring more work to your clients. Thank you for your time, and have a great conference.